Welcome to Precalculus Concept 24D underneath trig functions and unit circle. We're going to use even and odd trig functions to find exact values. 5 boxes here, so let me break this down for you. Let's talk about box number 1. What does it mean for a function to be even? Well, you may recall from chapter 1 that if f of negative x is equal to f of x, then f of x is what we call an even function. Okay, that's just algebra stuff. So how does that relate to what we're doing with trigonometry? So let me explain to you why it is true that the cosine is an even function. Okay, that's the answer. The cosine is an even function. Let's try and figure out why this is true. So take, for example, pi over 4. So let's take, if I'm looking at the cosine of pi over 4, right? And I want to compare that to the cosine of negative pi over 4 like I have in the picture. Cosines, as we have learned, deal with x values. So I'm going to go ahead and circle the x value there and circle the x value there. So the cosine of pi over 4 has an exact value of radical 2 over 2. And the cosine of negative pi over 4 also has the same value of radical 2 divided by 2. So are you noticing here that it is true that the cosine of theta, right, if I call that theta, and the cosine of negative theta are equal to each other because they share the same value of rad 2 over 2. Remember, this is what it means to be an even function if f of negative x and f of x are the same value. And here is one example of how they are. Now this works anywhere in the unit circle. I could have drawn another angle and called this angle theta and drawn the negative of that, negative theta. The x values would end up being the same. So therefore, it is true that cosine of theta is an even function. Okay, let's take a look at what it means for a function to be odd. You may remember in this green box here from chapter 1 that if f of negative x is the negative of f of x, then your function is odd. So why is it true that the sine function is an odd function? Well, let's take a look at the picture again. So I have for you on the unit circle, I have pi over 4, and we know that at pi over 4, our values are rad 2 over 2 and positive rad 2 over 2. And at negative pi over 4, this would be positive rad 2 over 2 and negative rad 2 over 2 because I am in quadrant 4. Okay, let's compare these two things, right? Let's take a look at the sine of pi over 4. Okay, and I want to compare that to the sine of negative pi over 4. And then I also want to compare that with the negative of sine of pi over 4. The reason I want to compare all three of these is because look at what the definition says, f of negative x and the negative f of x. So let's go ahead and start with the basic one. The sine of pi over 4, by now, everybody should be very comfortable with the fact that that is rad 2 over 2 in an exact value. Remember, the sine deals with the y coordinate, so the sine of pi over 4 is rad 2 over 2. Let's take a look at the sine of negative pi over 4. Negative pi over 4 would be this angle down here. Again, I'm looking at the y coordinate. So notice I get a negative value of rad 2 over 2. And then if I want to compare the negative of sine of pi over 4, notice that all I would have to do is to simply put a negative in front of that and put a negative in front of that. So therefore, this would give me the negative rad 2 over 2. And look what we have just worked out. We have just now seen that the sine of negative theta is the same thing as the negative sine of theta because these two values are equal. And this suffices to meet the definition. So therefore, sine is an odd function. Okay, box 3. This is what I call the summary cards of even and odd functions. So I want you to think of like 3 index cards sort of folded in half right here. So the sine is the reciprocal of the cosecant. So the definition that we just realized that the sine of negative theta is equal to the negative of sine of theta. So therefore, the cosecant of negative theta is the negative cosecant of theta. That's an odd function. Let's go ahead and do the other odd function, which happens to be tangent. Now, I didn't show you a picture of it, but it's for the same exact reason. The tangent of negative theta will be negative tangent of theta. and the cotangent of negative theta will be negative cotangent of theta. So the two outside cards are your odd functions. Your only even two functions are the ones in the middle. Cosine of negative theta is equal to the regular cosine of theta, which means the secant of negative theta is equal to the regular secant of theta. So think of these as three index cards, as odd, even, and odd, in the order that we're already used to. Okay, so how do we use this stuff? Here's how we do it. The cosine of negative pi over 4, find the exact value. Well, I know that the cosine of negative pi over 4 is the same thing as the cosine of regular pi over 4 because cosine's an even function. Therefore, this has an answer of root 2 over 2 in exact value. The tangent of negative pi over 4, I know that tangent is an odd function, so therefore this is going to be the negative value of whatever the regular tangent of pi over 4 is. Now, if we haven't talked about how to find pi over 4 for tangent, right, all you got to do is draw your picture, okay? This is pi over 4, 45 degrees, root 2 over 2, root 2 over 2. Tangent is the y divided by the x. So if I take this value and divide it by that value, notice you get a value of 1. So therefore, this is the opposite of 1. So therefore, the answer is negative 1. Okay, box 5 is you try. Find the exact value for the secant of negative pi over 4. Hopefully you got the right answer. The secant of negative pi over 4 is equal to the regular secant of pi over 4 because secant is an even function. And the secant of pi over 4 is 1 over the cosine of pi over 4 because the cosine and secant are reciprocals. We know the cosine of pi over 4 is worth a value of rad 2 over 2. And therefore 1 divided by rad 2 over 2, as we saw in many previous examples, is just radical 2.